This is section 2.3, quadratic equations. Just as a quick reminder, a quadratic equation shows up when we have something like this: x squared plus 3x plus 4 equals 0. So right here, that exponent of 2, that's what really makes an equation quadratic. Everything that we did for the last couple weeks, those were linear equations because it just had x's and no x squared. All right, so the zero factor theorem we're actually going to skip for just a minute. But first we're going to look at this little section about how to solve taking square roots. Now, this is just a tiny little section, and it is helpful in certain situations. Now, there's one thing that you have to be really careful of. It can only be used when there's one term. So usually that's going to be the something x squared on the left, and then something else on the right. This part's really important. We can't have an x value. So if you have something like 3x in your problem or minus 7x, you're not allowed to just take the square roots. Okay, then what it says is we're going to take the square root of both sides, and we need to remember to take both the positive and the negative square root. If you remember when we watched our video last week about imaginary or complex numbers, we talked that 9 is equal to 3 times 3, which is 3 squared. But then 9 is also equal to negative 3 times negative 3, which we write as negative 3 squared. So when we take the square root of both sides, there's actually going to be 2 roots. Once you're done there, you're just going to solve the equation and simplify, and you'll be done. All right, so let's look at example 1a. We notice there's an x squared on the left side. There's a 5 on the right side. There's no middle x value. So then I can just take the square root of both sides. Okay, on the left side, when you take the square root of x squared, we're going to get x. On the right side, when we take the square root of 5, that cannot be broken down. So it's just going to be plus or minus the square root of 5. This is probably the best way to write it. Sometimes you will have to write it as 2 separate answers. So for example, we could have square root of 5 and then negative square root of 5. Please make sure that the positives and the negatives stay on the outside of the radical. We don't want to give ourselves an imaginary numbers. Our example 1b is really similar. We do have this x plus 3 part here, but because it's being squared, this is really the same type of problem. So I'm just going to take the square root of both sides. Okay, and now the square root of a square just gives us x plus 3. And then over here on the right side, we do get plus or minus square root of 5. Now, we are trying to solve this problem for x. We want to get the x by itself. So we're going to subtract 3 from both sides. And we are left with x equals, now just like we talked about complex numbers, usually we do the real number first and then the imaginary. This is going to look similar. So we're going to go negative 3 plus or minus the square root of 5. So we're going to go usually the real number without any radical and then the radical, just to kind of keep in the same order as everybody else. All right, so now we're going to look at example 2, but before we get that, up here, this zero factor theorem, this is just kind of a theorem that says if we have 2 expressions, then p times q equals 0 if and only if either p equals 0 or q equals 0. Okay, so the easiest way to think about that, and what's really going on here, if you know that we're going to multiply 2 numbers and we're going to get 0. Okay, you can try positives and negatives. 3 times negative 3, that doesn't give us 0. Let's see, we could do fractions. 5 times 1/5, that does not give us does not give us 0. The only way to get 0 is if we do 5 times 0. And so what we decide to do then is we're just going to go ahead and set both factors equal to 0, just to kind of cover our bases and make sure that we've found the answer. Remember we talked when we go and solve equations, solving equations means to find all of the possible values of the variable that make the equation true. All right, so when we go to factor, first we need to set it equal to 0. Then we're going to factor just like we did earlier. We're going to set each of our factors or any of the factors equal to 0, and then we're going to solve those tiny little problems. All right, so my first step, I need to add x to both sides, subtract 10 to both sides, and now we're equal to 0. Now this one looks like it's a guess and check. Again, we are going to use all sorts of different types of factoring as we go throughout this section. So I do know this needs to be 3x, that needs to be x. This sign here tells me I've got one positive and one negative, and I know it's going to end up being 3x minus 5, x plus 2. Now, we are not done. Okay, we must set these factors equal to 0. I think that's the biggest mistake I see when people are working on these. You factor it, and then like here we thought, all right, x plus 2, then that means that 2 is the answer. And if you'll notice, the answer is actually negative 2. Okay. And there's our two answers, both 5/3 and negative 2. You must have both of those answers, or else you will only get partial credit. You're not all the way correct. All right, next problem, just like this factoring, let's set it equal to 0. Guess and check to factor. And I'm going to get actually x minus 4 times x minus 4 on these. Now, when you set each factor equal to 0, okay, obviously I can solve this first one and I get 4. If we solve this second one, we also get 4. Now, I really don't want you to write down x equals 4 2 times. Just writing it down once is going to be perfect. Okay, so again, a little bit of review here just in terms of factoring. It does not go away. All right, completing the square. Completing the square is a valuable tool. It is really helpful in some situations, but it's not one we're going to use often. But I do still need you to know how to do this correctly. Now, as we go through these, I think some of my steps, I don't love how I wrote them out. So step number 2, go ahead and cross that off, and then this part that's underlined, cross that off. I've sort of added in some other steps or some other thoughts that I think I actually like better. But I didn't think about that until after I know a lot of people had printed the notes out. Then also, let's go ahead and move step 7 up to right between step 1. Actually, it's going to replace step number 2. All right, so I'm going to do example 3. I encourage you to kind of look at your steps as we are doing this problem. Okay, so step 1 is to get the constant on the right side. So the constant is 20. So I need to move that 20 to the other side. And it's going to look like that. Now, our new step 2 is actually to divide everything by the GCF. The GCF, or actually it's going to be the coefficient in front of the x squared. If you notice, this one has a coefficient of 1, so we don't actually have to do anything. Now, our next step, we're going to calculate, or we're going to decide what b over 2 is. So b is my middle term, negative 10 over 2, and that gives us negative 5. Now, steps 4 and 5, we're going to do something with step 4. We're going to do something with step 5. One of them on the left, one of them on the right. Now, these two steps are the whole idea of completing the square. What we're actually trying to do is to get a problem like 2b, where if we were to take the square root of both sides, we'd actually get the same factor to show up twice, and then we can solve it a little bit easier that way. So it's an easier problem to factor. All right, so here's what I'm going to do. Now, I'm actually going to leave out a few steps just to kind of show you what's happening. But again, this is supposed to be a shortcut. So on the left side, we're just going to write x minus 5 squared. Okay. Now, again, you sort of need to look at some of the steps. It says step 6, we're going to write the left side as a binomial squared. This is what we did right here. So I'll write this off to the side in purple. Really, what I did right here on this step, I took x squared minus 10x, and eventually I'm going to take negative 5 squared and get 25. Now, if we went through and factored this, we'd get x minus 5 times x minus 5, which is also equal to x minus 5 squared. Okay, that's how that shortcut comes into play. But going forward, I would really like to just see you guys take b over 2, and then just go ahead and write that as part of your answer, x minus 5 squared. And actually, I'm going to move this down a little bit because I need a little bit more space. So x minus 5 squared is part of our work down here. Now, on the right side, I need to take negative 20. And then I am going to go ahead and take this negative 5 squared thing now. I'm going to square it. Negative 5 times negative 5 is positive 25. And so I'm just simplifying my right side. Negative 20 plus 5 is 5. Now, this should look very similar to our example 1 that we did. At this point in time, we're just going to go ahead and take the square root of both sides. So I'm going to get x minus 5 equals plus or minus the square root of 5. We need to add 5 to both sides. And there's our final answer. Okay, we're going to practice a lot with completing the square. It is kind of a weird set of steps, but it is definitely helpful, and going forward it's going to be helpful for some different topics that we're going to work on. All right, example 4, completing the square again. First I got to move my constant. Now this time I do have a GCF, so I'm going to go through and divide every single thing by 4. Now you'll notice on the left side this just gives us x squared plus 3x. So it's actually a little bit nicer, but over here this part is not as nice. We're just going to leave it as negative 11 over 4. Now please just leave it like that. Don't turn it into a decimal. I'm telling you that more than likely there's going to be a time here throughout this problem where we want something as a fraction with a denominator of 4 to make it easier to reduce. All right, now I'm going to follow my same steps. I'm going to take b over 2. So I'm going to take 3 over 2. That can't be reduced at all. And so remember my left side, I just get to write x plus 3 over 2 squared in parentheses. Okay, that's the left side. Now on the right side, we need to square this. Let's see, when you square a fraction, you just multiply top times top, bottom times bottom. So 3 squared is 9, 2 squared is 4. Oh, and you should see it. Now we actually do have a common denominator of 9 over 4. Add those together. Let's see, negative 11 plus 9 is negative 2 over 4. We could reduce this. I'm going to go ahead and leave it like this just for the time being to kind of see what happens. So this is negative 2 over 4. Now I am going to take the square root of both sides. And on the right, I'm going to move over. I need a little bit more space. Over here, on the left, we get x plus 3 halves. On the right, all right, we got to really think about this. The bottom's really easy because the square root of 4 is just 2. But on the top, we've got the square root of negative 2. So let's think. 2 can't be broken down, but because we've got those negatives, that tells me it's going to be I. Okay, the square root of negative 2 is actually I times the square root of 2. I'm taking that negative 1 out. Now, we do need a plus or minus just like everything else. And actually, now I'm actually ready to solve for x. I'm going to subtract 3 halves from both sides. And again, because I've got that I, it is a complex number, so I'm going to go ahead and leave it as negative 3 over 2. There's my real part, plus or minus. Actually, I'm going to split these up and write them separate. So plus I square root of 2 over 2, and then x also equals negative 3 over 2 minus I square root of 2 over 2. So that's why we kind of did complex numbers first, because now we're able to look at problems and deal with them if they have any sort of imaginary numbers in the answer. So that's going to be the end of video 1. I'm going to actually split this up. Part 2 is just going to talk about quadratic formula. So we will get to that here in just a minute.